Have you ever stopped to think that maybe, just maybe, there's a hidden blueprint to a lot of things in our daily lives? From your phone bill to a mechanic's quote? Well, there is. And today, we're going to pull back the curtain and take a look at the simple, powerful math behind it.
So, let's imagine the worst. Your car breaks down. Ugh. You get it to a mechanic, and as they start looking under the hood, that little voice in your head starts up, right? What's this going to set me back? You know it's not going to be just one flat number. So, how do you even begin to guess the final cost?
Well, a lot of the time, it's actually pretty predictable. The mechanic's probably going to have a flat service fee, just to get started. Let's say it's $50. Then, on top of that, they charge for their time, a steady hourly rate. We'll call it $100 an hour.
And right there, that simple two-part pricing, you're actually using one of the most common and useful ideas in all of math. This is a perfect real-world example of something called a linear function. It's just a fancy name for a pattern of steady, predictable change. So let's actually look at the blueprint behind this whole thing. And don't worry, it might look like a formal math equation at first, but I promise you, it's really just a simple template for figuring out pretty much any situation where things change at a steady pace.
Okay, here it is. f of x equals mx plus b. Now, I know. Letters in math can be a little intimidating, but stick with me. This is our master blueprint. Just think of f of x as the final answer we want, like the total bill from the mechanic. And m, x, and b are just the simple pieces of the puzzle we need to find it.
Let's start with the easy one, b. That's your starting point, your base value. In our mechanic example, that's the $50 service fee. It's the cost you pay right out of the gate, even if they work for 0 hours. It's the fixed foundation of the total cost.
All right, now for m. If b is the foundation, m is the action. It's the rate of change, the part that's actually moving. For our mechanic, m is that $100 an hour charge. For every single hour that clicks by, the bill goes up by exactly $100. It's constant. It's predictable. That's m.
Now, in the world of math, this m value, this rate of change, gets a special name. It's called the slope. And honestly, it's the perfect name because it literally tells you how steep the price is going to climb. And the idea of slope is way simpler than it sounds. You just got to remember rise over run. Think about building a wheelchair ramp, right? For every foot you go forward, that's the run. How many inches does the ramp go up? That's the rise. It's the same thing with our mechanic. For every 1 hour we run forward in time, the cost rises by $100. And you can see it perfectly right here. At hour 0, before any work starts, you're at that base fee of $50. Then, 1 hour of work goes by, boom, add $100. Now you're at $150. Another hour, boom, another $100. $250. See that? For every single hour we run to the right, the cost rises by a steady $100. That is our slope in action. Okay, so we've totally nailed down the slope, that m value. Let's circle back for a second to that other crucial piece of our blueprint, the b value, our starting point. So if you were to draw this on a graph, b gets another special name, the y-intercept. But all that really means is it's your starting point on that vertical up and down line. It's the value at time 0 before any of the change actually starts happening. For our mechanic, that's the $50 fee, plain and simple.
All right, now for the really cool part. You don't just have to understand this blueprint, you can actually build it yourself for any situation. All you need is just 2 little pieces of information, just 2 data points, and you can figure out the entire pattern. Let's try a totally new scenario. Say you're looking at a gym, and they tell you that a membership with 2 training sessions costs $125, but 5 sessions will cost you $260. It kind of sounds like a word problem from school, right? But we actually have everything we need right there to find the blueprint. So how do we crack this? First, let's find that rate of change, the m. The cost went up by $135. That's $260 minus $125. And that happened over 3 extra sessions, 5 minus 2. So $135 divided by 3 sessions. That gives us a rate of $45 per session. That's our m. Now we just take that, plug it back into the blueprint with one of our original points, and we can solve for b, the base membership fee. See? It's just a puzzle.
Seriously, once you get the hang of this blueprint, you're going to start seeing it absolutely everywhere. It's not just for mechanics and gyms, it's a fundamental pattern for how so many things in our world work. Let me show you a few more.
Take a scuba diver.
The starting value, or B, is just the normal air pressure at the surface of the water, and the rate of change, or M, is that 0.434 psi. For every single foot deeper they go, the pressure goes up by that exact constant amount. It's a perfect linear function.
Or what about a salesperson's paycheck? Their starting value, B, is their weekly base salary, $520. The rate of change, M, is the commission, an extra $80 for every single policy they sell. Their total paycheck follows that same simple blueprint.
And you can even apply this to huge things, like the population of a city, as long as the growth is steady. Here, the starting population back in 2008 is RB, and that rate of change, our slope, M, is a steady increase of 1,100 people every year. It's the same pattern, just on a much bigger scale.
So here's the bottom line. From your phone bill, with its base monthly fee and then a charge per gigabyte of data you use, all the way to how fast a bamboo plant grows, any system that changes at a constant steady rate follows this one simple blueprint. F of x equals mx plus b.
You know, this isn't really just about spotting patterns. It's about having the power to predict things. When you understand the blueprint, you can predict costs, you can plan for growth, you can make smarter choices. It's the math of being able to see what's coming next. So now that you have the blueprint, my question to you is, what predictable change are you going to notice out in the world today?